welcome to Chapter 19 homework. We're going to go over the conceptual questions now. The first conceptual question, number 3, what is the relationship between voltage and energy? Voltage is joules per coulomb. We just refer to that, the unit is volts, but when we want to know what that means joules per coulomb. And electric potential energy is the actual energy that a particle would have inside an electric field or whatever. So that would be the energy in joules. So when we make that distinction, voltage is the energy per unit charge. So every coulomb with 100 volts, when a voltage of 100 volts, 100 joules per coulomb, acts on 1 coulomb worth of charge, that will be 100 joules worth of energy. When it acts on 2 coulombs worth of charge, that'll be 200 joules of energy. So there's number 3. Number 6, discuss how potential difference and energy field strength are related. Well, that's a similar kind of idea. Energy field, then, is newtons per coulomb. That tells us how much force is exerted per coulomb of charge, but it's also equal to volts per meter. So if we're describing an electric field between 2 plates of a parallel plate capacitor, then we can say, hey, the field strength here we can determine by saying that it's 100 volts over a distance of 1 meter, so the electric field is 100 volts per meter or 100 newtons per coulomb. That's all great, but we also have the ability to say, well, hey, you know what, for the voltage, that means for every 1 meter there will be a potential difference, a voltage difference of 100 volts. Potential difference, voltage, EMF for our purposes, we'll talk about electromotive force coming up, all of those things are in volts, and they're all that basic idea of voltage. All right, number 14. Looks like we're exploring what words mean and what the units are. Capacitance. When we hold a capacitor in our hand, and the symbol for a capacitor looks very close to that of a battery short on one side and long on the other side, and that's a voltage source, voltage, or a battery. A capacitor is a device. It's a device that you can hold in your hand, and that capacitor is rated at 450 microfarads. That tells us something about what this device will do, but then we need to know what we're hooking it up to. Turns out that Q equals CV. The quantity of charge in coulombs that will be stored on this capacitor depends on the voltage that we hook it up to. If I hook it up to a 1.5 volt battery, it's not going to store a whole lot of charge. If I hook it up to a 120 volt power source, it's going to hold a whole lot of charge. So that's the deal. So the capacitance does not depend on the applied voltage. It has the same capacitance, whatever voltage source I hook it up to, but the quantity of charge that it will store does depend very much on the applied voltage. Those are the conceptual questions. I hope that helps.